Hello guys, this video is in continuation of your earlier class. We were at the middle of derivation of maximum regulation at lagging power factor. So we came across tan phi as in terms of Vx by Vr, and Vx by Vr, if I substitute the values of those, means I can get x1 by R1e as well as x2e by R2e and refer to primary and refer to the secondary. So coming to this cos phi as well as sin phi, how these formulas came? If you divide sin phi by cos phi, you can see either you can take x2e or R2e z2e at one set, as well as x1e z1e as well as R1e z1e as another set. If you divide, what happens? Z2e z2e gets cancelled, and again remaining what I'm going to get here is x2e by R2e, and sin phi by cos phi is tan phi. Okay, so this is how they have written this. So we can split this tan phi formula like sin phi by cos phi, and sin phi answer is what? x2e by z2e. Okay, and cos phi is whole divided by R2 by z2e. So z2e gets cancelled, so remains here is x2e by R2e. Similarly, you can do for here x1e, z1e, R1e, z1e. Okay, again divide one by the another, you'll get the answer. So coming to this derivation here, we know that tan phi is positive at lagging power factor, and again we know that maximum regulation will occur. Okay, so when tan phi is equal to x2 by R2e, or when tan phi is equal to x1e by R1e, then what happens? Maximum regulation will occur. So again I'm going to consider this condition here, the first condition, this thing. Okay, so instead of percentage R, I'm going to write it as what? R max, because we're going to find out the condition for maximum regulation. So R max I'm going to substitute there. Okay, any of that 100 is removed and all. So we are into cos phi it is, and cos phi formula is what? It is R1e by Z1e. They have taken consideration. You can take either primary R1e or R2e, but since they have taken R1, let us be with this. And similarly, plus Vx, sin phi is there. Sin phi is nothing but what? X1 is Z1e. They have substituted over here. Yeah? Then we know that Vr is equal to I1 R1e by V1. Already we have dealt. I could have written with respect to the secondary side also, but since primary side is used here, so we have written what with respect to the primary itself. And similarly Vx is equal to what? I1 x1e by V1, which you are already seen how this formula has come and all. And again what I can do here is I can take I1 V1 Z1e as common, because on the both sides, because these are the common things, and the things which remain inside is R1e square plus x1e square. But we know that R1e square x1e square, I can replace it by what? Z1e square. Okay, that is equivalent impedance and refer to the primary. Fine. And again we know that when I replace this, and what I'm going to get here is I1 Z1e square divided by V1 Z1e. So Z1e gets cancelled. The what answer remains is I1 Z1e by V1. So this is nothing but what? ZPU. So maximum regulation is occurred at this particular condition. Okay, that is I1 Z1e by V1. So thus maximum regulation is equal to the per unit value of the equivalent impedance of the transformer. Okay, this they have written in the form of the ZPU. Otherwise you can remember like this, or you can remember the single R max equal to I1 Z1e by V1. Anyhow, both will help you. So please to remember in the both ways, because I into R is nothing but voltage and V is voltage. So voltage, what happens? Both are having same SI unit. So what happens there? So both SI units gets cancelled and they will be termed in terms of per unit. Okay, so R max has no any SI unit, so that's why it is also called as impedance per unit. Okay, so this is the condition where you are going to get the maximum regulation. Now let us move to the topic all day efficiency of a transformer. Okay, so what is all day efficiency of a transformer and what is commercial efficiency of a transformer? Are they both same? No, they are not same. Let us see how all day efficiency as well as your commercial efficiency of a transformer vary. Okay, look here, commercial efficiency or power efficiency is measured at full load on a particular transformer at a particular period of time as well as on a particular load. But whereas all day efficiency, it is applicable to the distribution transformers, where your distribution transformers are applied with continuously variable loads such as inductive, capacitive as well as resistive. In that case, what happens? Load will be sometimes high and load will be sometimes less. So we need to account for whole 24 hours. So in that case, what happens? Commercial efficiency would not be right, or true efficiency would not be a right parameter to judge the efficiency of a transformer. So we are going to judge the transformer efficiency by using all efficiency. So commercial efficiency is only true for only what? For a certain period of time as well as a full load. But our distribution transformers are not loaded fully. Usually, as per study, we have come to know that they are loaded around 30 to 40% of full load only, or even less. So in that case, what happens? We are not supposed to use commercial efficiency or power efficiency. Instead of that, we need to go with the all day efficiency. Okay, for all the 24 hours. And again, you can see here the core loss, which depends on the supply voltage. So what happens? Core loss will be always constant, which is irrespective of the load connected, whereas your copper loss is depending upon the load. Yes or not? So in that case, what happens? Again, your copper loss will vary. So in that case, your efficiency also vary at different time period and all. So in that case, what happens? We need to go with the all day efficiency, not with the power efficiency. Okay, so all day efficiency, it is again, remember, it is measured in terms of kilowatt hours. Okay, the energy output is measured in terms of kilowatt hour. In earlier class, we measured in terms of kVA. Yes or not? But here in efficiency, all day efficiency, we are going to measure the output in terms of kilowatt hour, as well as input supplied to the transformer is also measured in the kilowatt hour. So it's a ratio of all efficiency is the ratio of total energy output to the total energy input. Such ratio is called as energy efficiency or all day efficiency of a transformer. And again, here the formula is in much more elaborated fashion. So output energy in kilowatt hour during a day. During a day means what? All 24 hours I'm going to consider. Whereas output input energy in kilowatt during a day. Output by input. Okay. And again, input can be also written as what? Output plus losses. Yes, here output energy also in terms of kilowatt hour, as well as energy spent for total loss also in terms of kilowatt hour. Each and every aspect in this formula is what? In terms of kilowatt hour. And just multiply by 100 to get in terms of percentage. So here what happens, since core loss are constant and rated voltage is continuously applied to the primary side of the transformer, and again load is connected at the secondary side of the transformer. So load sometimes vary, it may be increase or decrease, but the applied voltage will be always constant and rated thing. So constant loss will be a little bit high here, because you are running a transformer whole day, not for a certain period of time. So what happens there? So we need to keep the core losses minimum as possible, and this can be done by what? Reducing the flux density of your core to lower value. That can be done by having what? Larger iron to copper weight ratio. Means I need to use what? More iron and less copper, so that what happens? The flux density in the core can be reduced. Yes or not? The flux density can be reduced by limiting the core flux density. So that by using the, what happens? We get what? Higher that can be achieved. That can be achieved by using what? Higher core cross section area of your core part of the transformer. In that case, what happens? The core losses can be minimized. And again, you can see that the maximum efficiency of such transformer will be in between 60 to 70%, and not 80 or not 90 plus and all. Remember always, the all day efficiency of a distribution transformer will be in between 60 to 70%. Okay, that's by proper designing we can reduce the losses, core losses. Any of copper loss depends on the load. Core loss also we can be reduced by using what? Proper design.